Hey guys, welcome to my YouTube channel. Today we'll be talking about representation of forces and support reactions. Please stay tuned. From our basic knowledge from strength of materials, we have the point load, assuming this is the beam. This is a point load. Then we also have the uniformly distributed load, which could have two ways of representing it. This way, and we also have this way. So this is the point load, and then this is the uniformly distributed load, UDL. UDL basically means that at each unit length the forces applied are equal. So if I should cut this beam in half, the load that we have here is equivalent to the load that we have here, but it is distributed equally over the span of the beam. Then thirdly, we have the gradually varying load, which is like a triangle. So you can see that gradually the amount of force that is acted upon by this load on this side is different from this side. So you see that it is gradually varying. That is, from here it is quite minimal, and then gradually it is increasing. Gradually varying load. Then a beam can have different type of support reactions. We have number one, the pin support or hinge. Number two, we have the roller support. And then number three, we have the fixed support. So how does the pin support look like? The pin support, it is like this. This is the beam. This is the representation of pin support. Pin support. And how are the reactions on a pin support? A pin support has two reactions. One in the vertical direction, assuming this is A and this is B. So this is RA, reaction A. In the vertical direction, RAY, RBY. And then we also have one this way. And let's call this RBX in the horizontal direction and RAX. As easy as that. Then in number two, we have the roller support, which is something like this. It could also be in this form. A pin support has just one reaction. This is A, B, that is to say RBY, RAY. Then on the third side, we have the fixed support. This shows that it is fixed. This is how the reaction would be like. One in the vertical direction, RAY, another in the horizontal direction, RAX, and a moment, MA. It could be clockwise or it could be anti-clockwise, depending on the way you want your orientation to be. But I would prefer my own going clockwise so that I can easily identify the direction. So if you want to change it to anti-clockwise, you just easily, put your arrow on this side. So it shows that it's going like this. So that would be the end of today's session. In our next class, we'll be talking on statically determinate and indeterminate beams and redundancy, internal and external stability of trusses.